today. We are super happy to have someone that honestly I've never interacted with, but we know each other. I know she knows me. I know her. I know we all know the same people, but we've never really interacted before. So Dr. Melinda Hutson is here today, and I am super happy to have you here. Welcome.
Thank you.
Okay, that is the end of our prepared conversation. I don't think of these as interviews as much as a conversation. So I hope that felt comfortable and a conversation to you as well. We really honestly appreciate your time. Cannot believe of the caliber of guests we're having on this show. So thank you very much, Melinda. We are going to break off for any questions. So
Yes.
who's in charge of that?
Let's go over to Ben Fissler, another crew member of ours.
Give me 1
Ben.
second. I need to add-
Oh,
Okay.
Melinda, I spend a lot of time in the field, and I was just curious if there was any of the recent falls that really piqued your interest at the university.
I don't keep track of the recent falls. Every once in a while I go through and see what has fallen in the last few years. You know, there's places online you can find that. And I try to see if there's any pieces that I can afford to get, because it's nice to have fresh, unweathered material for research. And sometimes I'm successful and sometimes I'm not. I like falls and I don't like falls. I like falls because they're fresh and you don't have as much problems with weathering. I don't like falls because there's sort of a bit of a feeding frenzy associated with it. And I don't like stress. So I know in the past there's been competition to see who would get something classified first. And I don't want to be somebody that gets material that somebody else has already got, because that's wasting resources. It's wasting time. It can potentially cause, conflict between different researchers. So that said, last year I wound up participating in 3 fall classifications, quite
that's great.
unintentionally. So I can blame Daniel Sheik for 2 of them. He'll have to weigh in on those. So one of them, somebody, I believe it was Matt Stream, and Daniel will have to say who it was. Matt Stream and somebody else, and I'm blanking, sent a small amount of material to Daniel, and he came and talked to me and said, I talked to Mark Fries, and he and Linda have samples and we're thinking about classifying it, and I don't know what to do. And I said, don't worry about it. I know Mark and Linda. I've been out, in bars with them. Don't tell. Never mind. It was a pub, and their teenage kid was with them, so it's not bar hopping. But yeah, they're very nice people. We can talk to them and we'll make it work. And so neither one of them is a petrographer. So Daniel and I actually did the petrography needed for classification. They were just concerned because they had worked up a new technique for finding where a fall would fall using weather radar, or weather, not even radar. So anyway, they had a new technique. And so we all got together and were a large, happy family. The only snag came that we didn't have enough for type specimen. So X-Space at NASA had a new lab that was going to be dealing with meteorites, and they had sent a crew out to Cranfield to get their own sample, and they didn't have enough sample. So we all sort of joined together and had enough sample for a type specimen. That was the only hairy bit about it, was how do we get enough stuff? But Daniel and I actually did all the petrography that's needed, the write-up geochemistry and all of that. that was the two of us. And, you know, Linda has written a couple of abstracts and put our names on it. She's been very gracious about it. It worked well as a team. So I was very happy with the way that worked out. Daniel came and said he'd been contacted by people from the Philippines, and the next thing I know, we're, you know, doing Pongo. And then I'm like, okay, well, we had enough excitement, we're done. And I get an email from Jim Kerner. He's at University of Utah. He's done a lot of geochemistry on lunar meteorites, but he had never classified a meteorite ever. And so he was, you know, Sonny Clary found a piece of the Salt Lake fall and presented it to Jim Kerner. And Jim realized that not only had he never classified a meteorite, but B, there weren't any repositories in Utah, and his university wasn't interested in trying to become one. And somebody referred him to me. So the next thing I know, I've got an email and I'm working with Jim Kerner on that one. So it was an interesting year last year. And I'm like, okay, that's probably enough for the next decade. We'll see.
That's wonderful. I think I bumped into you and Dick at the 2019 show at Adam Aronson's, and that was when he was only selling material by the kilo, and I think I gave you a name that you went to and found better pricing.
I remember that. Yes.
But yeah, I definitely understand the limitations of a budget on the university level, and who knows what you're going to find this year. What with we've already got a new fall and a new year.
Well, I will put in a little commercial right now. I don't have a budget for purchasing meteorites. So I occasionally write a personal check and donate the sample to the lab.
Oh.
Okay. I have zero budget for purchasing meteorites. So I am always happy to receive donations. I've occasionally twisted arms begging for donations. So anybody that feels like donating, we'll be happy to take any samples that you want to donate our way. And if you don't, well, that's fine too. But
Remember,
yeah,
20 grams is the absolute legal minimum.
well, that's for classification.
Yeah.
I've had, you know, there are a couple of people that I've worked with for years on classifications. And one of the reasons I do is they give me gifts of stuff that somebody else has classified. And it's not 20 grams, but it's enough to do research on. I
Okay.
often only need a small piece in order to do a thin section and a little bit of bulk chemistry. So I really appreciate that.
Well, I'm glad you put a little plug in there for yourself. Do we have another question?
Yes, I did want to say that Daniel did mention in the chat that the person that donated or gave the meteoritic material from Cranfield was actually Roberto Vargas,
Oh,
who we had a
yes.
question from earlier. And then also you mentioned Pongo, and he's not on anymore, but Christian Cruz was on earlier in the hour, and he actually was the person from the Philippines that worked on that. And he's mentioned that on a previous Hangout working with you. So
Yeah,
just had a
he's very nice.
super, super nice.
Yes. I was very surprised he sent like a gift box with like Philippine bags and all sorts of stuff. My kids were thrilled. A little bus. I mean, yeah, he was very nice to work with.
Oh, yeah, he's super nice. So I want to check and see if Allison's available again. I know she must have been stepped away last time. If she's not, I will ask her question for her. Earlier in the conversation, Allison said that you mentioned that they like to teach meteorite misconceptions and realities, and she wants you to expand on that a little bit more.
So, one of the common misconceptions is if it falls from a sky, it's a meteorite. And the answer is not necessarily. Lots of things fall from a sky. The past few days, we've had the door from a Alaska Airlines plane and people's cell phones falling from the sky with a blowout. I don't know if you're aware of that. It was big news here anyway.
Oh yeah, we heard about it.
I have a friend in Wisconsin. Somebody was dropping pumpkins one Halloween from an airplane, and it made a holes through somebody's roof. I know that there's a a, a, a copper meteorite that turned out to be a piece of a Pratt and Whitney airplane engine, but it actually wound up being thought of as a meteorite when it first fell. It was an old one. Dick Pugh liked to chase down mysteries. There was a rock that came through a car window on the Pacific Coast Highway, and best that he could figure out, it was spun up by a semi wheel because it was clearly a piece of a rock, but that particular formation wasn't within 20 miles. There was another one that he chased to several miles away where they were doing blasting in a quarry, and a thing got launched and came down somewhere else. So just because it falls from the sky doesn't necessarily mean, and we won't go into space junk. I mean, there's all sorts of stuff that's coming through. Rocks can fall from wheel wells. It's like, I don't know why your rock fell from the sky, but it doesn't mean it's a meteorite. The other one is, I saw it fall and it set things on fire. How many pictures have you seen of a real fall that has gone through, say, a roof that's a straw roof or a wooden roof, and there's a hole, but it didn't set the building on fire? Meteorites are basically the temperature of outer space. If they're in the sun, they're warm. Look at what the temperatures are on the moon. It's like, I don't know, 140, 150, something like that. If you're directly in the sun, and it's like well below freezing if you're not. And so it depends on whether you come in from the shadowed side or the lit side. And it breaks up, and it's a fireball very, very, very briefly. And if you look at a fusion crust, that doesn't heat the interior. It's a really thin layer of glass. It's a poor conductor of heat. So it lands, and maybe it's really warm because it was sunlit, or maybe it's really cold. When I was an undergraduate, I worked in a lab with Calvin Alexander, and most of you people won't know him, but he's sort of an unofficial curator of a meteorite collection at the University of Minnesota. He's the one that actually got me hooked on the NASA undergraduate internship. And he liked to tell a story about a meteorite that fell in snow, and the people got out there to pick it up. I'm switching from apples to oranges. There are meteorites that have freshly fallen that people see frost on. But my favorite find story was, this landed in snow. People went out there, and of course it didn't, melt a big pile of snow. It's just sitting there in the snow. And he said they were the first people to find it, but they weren't the first terrestrial beings. There were little wolf prints or coyote prints, some kind of dog prints going up, and a big yellow stain. So we'd had biological contamination of the meteorite.
Oh my God.
Never mind. That's my favorite found meteorite story, is that one. But sometimes they're warm, sometimes they have frost. They don't start fires, but everybody's like, oh yeah, it set this whole thing on fire, and there's charred this and charred that. And it's like, nope, that's not. Sorry,
Yep.
that was long-winded, but never mind.
No, we like when you tell stories, so feel free to be long-winded.
Yeah, thank you, Sue, for asking my question, and
Oh,
thank you, Melinda,
sorry,
for the
Allison.
answer. Oh, I just couldn't. I've got a new device and I couldn't find the buttons in quick. So thank you, Sue and Melinda. I appreciate that.
No, we got Pat Burnell with his hand up.
Thank you very much for coming and doing Q&A with us. This is an amazing honor, and the work that Topher and Sue have done on this is just outstanding. I am very, very interested in the cluster chondrule stuff, and it got me thinking. My specialization are low subtype 3s. I've been working with Daniel and Vince on these. Do we know anything about the initial accretion process? Because some chondrules, like the bleached chondrules, they bleach from contact with liquid water as a free-floating chondrule, and then later accreted into a rock. and I've been trying to read the stuff in the literature, and there's just a sparse amount of stuff. Can you speak to those very first parts of accretion?
This is basically a cosmic sedimentary rock. You have beads. They're clearly 0G. You know, the astronauts spilled their tang, little spheres of liquid floating in space. They have to be in a, they can't be floating in space by themselves. They have to be close enough to other chondrules, to dust, to CAIs, to whatever, that they can all get put together into a chondrite. The cluster chondrites tell us that at least some of them were still soft and squishy when they were put together, because they come together and they sort of deform around each other. And in some cases, you squeeze material out of the chondrule and it winds up in between the chondrules. That's been referred to as like white matrix, among other things. In other cases, you can see where you've accreted or at least recycled chondrules that were thoroughly solidified because they've got little teeny impact craters in them. You know, they've got pieces missing. So again, you're talking about a fairly complex problem. And are you doing this on the surface of a parent body? Are you doing this above a parent body in a shock plume, a vapor plume that's full of chondrules and vapor? Is there some sort of shock wave that's concentrating material in particular places? That gets back to chondrule formation. So the answer is there's lots of different ideas, and I'm not going to admit to supporting any one at the moment.
Say
Because-
it. Say it.
No, I'm not.
I really, really look forward to Alex's paper. We got some teasers at the MSOC meeting.
Yes, you did.
Really
So-
looking forward to reading that in its completion when it runs the gauntlet of the review process.
Yes, it's submitted. It needs to go through the review process and get published. So yeah.
Thank you.
We have another question, and it's going to be from Jeremy. And just wanted to also, before Jeremy asks his question, give a shout out because Melinda, we have a few people that you work with that join us every now and then. We have obviously Daniel, who's our preferred classifier, and Vince has been a recent addition, and also George Amon. I think that's how you say his name. He's come and talk with us a few times as well. So we love the people that you work with. They're really great. So that is going to hopefully be a good segue into Jeremy's question. So Jeremy, are you ready to jump on?
Yes.
Thanks.
Okay. Well, thank you for your contribution to meteoritics. It's really cool to see how many times Cascadia is mentioned in the Met Bowl as we're going through. And so Daniel's one of the highly regarded people in our circle. I just wanted to know if you could share maybe your favorite collaboration with him, or maybe a highlight of a collaboration with him, with the group.
If you can think of one.
What's your favorite?
Which of the several will I come up with?
Yeah.
I would say that it was fun to do the classifications of Pongo and Cranfield with him, because instead of him coming in as sort of a student, talking about, okay, we're doing this research and, you know, where should we go from here? It was sort of like we could sit there and just chit chat like peers as we were watching the data come in on the SEM and discuss, okay, well, you know, look at this. This looks kind of interesting. Oh yeah, that's kind of, well, where should we go now to, you know, get a representative sample? Oh, let's go over here. So that was fun in the sense that at those moments, Daniel was a peer rather than a student, if you know what I mean.
Yep.
Awesome. So we've been very fortunate in having an excellent crop of students for the last several years. We've had very good undergraduates, but we have excellent, excellent graduate students. So, and Daniel is clearly working on becoming a replacement for Randy Korotev at the moment. His PhD, of course, is in lunar meteorites, so he's been spending a lot of time there.
Thank you so much.
Yeah, thank you, Jeremy. Yeah, I was actually kind of surprised earlier when you said you didn't have a favorite meteorite, just whatever. Like with Daniel there, you should have a crap ton of lunars laying around.
We do. Yes, and some of them are quite interesting, and some of them he hasn't gotten abstracts yet out, so I'm not going to talk about his work.
Does he
so-
drive you crazy about his PASs as well? Pink spin or PSAs?
Not crazy. I find it
Oh.
fascinating.
Nice. I jest because one of the great things about my position here is I get to edit this and I get to then digest it. So when I have Daniel on doing a from the lab episode or classification or just giving a thing, a lot of it goes right over my head, and it's not because he's using too big of words to sound important, but he's explaining things from a scientifically accurate point of view. And it just takes a while sometimes to hear it 3 and 4 times before it all sinks in. But yeah, see, I couldn't even get the joke out of PSAs. I couldn't remember the acronym. So yeah.
So here's the thing. I have taught for 20 something, almost 30 years, intro level geology classes and astronomy classes at community colleges, which means that I can't sound like Alan Rubin or Daniel or even Alex, because none of my students would understand me. So I tend to probably sound a little bit less professional than somebody who hasn't had to explain astronomy and geology to 100 level non-majors for decades.
But your explanation earlier was 45 minutes shorter than both those guys, so it paid off. I'm gonna look around one last time. So do we have any other questions for our esteemed guest?
Oh, and just to mention the you're talking about lunar. Oh, Pat has a question, of course. But yeah, Daniel gave us a little lesson on lunar classifications last week that I found really fascinating. And like Topher was saying, he explains things in a way like I didn't grasp everything, obviously, but I got a better understanding than I would from other people because he just explains it in a way that he's not dumbing it down, but he's making it really easy to digest. So yeah, he's doing great work and probably learning a lot from you. So let's turn it over to Pat.
I'm just starting to work with Vince, and his enthusiasm is so infectious. It looks like he's following in Daniel's footsteps and wanting to just get tons of interesting stuff classified. And he has latched onto some high pressure mineral ideas in shock veins, especially in type L chondrites. I think I see another shining star in one of your students. Can you give me any dirt on them? They're going to be at the MetSoc meeting next year. So
I would say that Vince is in fact very enthusiastic. He has an inquiring mind, which means he's read a lot of papers. When you get a graduate student, you get the ones that read just what they need to know to get through their thesis, or you get the ones that dig into everything because they're curious and they want to know. Daniel and Vince are both, as are George, Anim, and Benjamin, who's our new student. All of them are very well read and they have breadth. And they're curious and they go digging. You set them a problem and they go looking for references. So those are the kinds of students that you always hope you're going to get. And as I said, we've been very lucky. Vince is very enthusiastic. He wants to do everything. He does have to work on his master's thesis, which is on veins that have the high pressure polymorphs. we started, I will tell you a story. We started with the classification of material out of the Franconia strewn field. So Buck Mountains 005 was one of the ones that I was classifying. And we're always short of funds. So students take the scanning electron microscope class and they get free time on the instrument. And I've been known to use the data to help classify meteorites. So I had an undergraduate, Ryan Brown, who was interested in, he didn't know anything about meteorites, and he needed a project. And I said, well, I'm classifying this and I need data on it. And so we got the data to do a classification, but we'd made a couple of thin sections, and one had a very elaborate, you would actually call it a shock dike. It had like sections. So there was an outer section and an inner section, and they were texturally different. It was a really thick vein. It's, you know, bigger than a typical shock vein. And so Ryan got the bug. And so he did an undergraduate thesis working with me and Alex, characterizing the vein, specifically the metal sulfide component. And he gave a presentation at American Geophysical Union meeting, and someone, and I'm going to say that I've forgotten the name, might have been Gretchen Benedicts, I'm not sure. But someone saw the poster, was very impressed, and asked Ryan and Alex to do a paper on this for a special edition of American Mineralogist on core formation. Nobody ever finished the silicate portion of the vein. So when Vince came in, he was offered a couple of different topics, and the veins grabbed him. So, and I keep track when I do a classification, I find something weird, I keep track of it. So I had other samples with veins, different types of veins. And so he's working on some of those, and he's found a couple of other interesting ones in some unclassified stones that Dick Pugh left. So that's where his thesis will be. And yes, he has to do it in about 2 years. So my only concern with Vince is that he's so enthusiastic, he might get into too many tangents and have trouble actually completing the work on the veins. So we're going to keep him on track, folks, right? We're going to only give him samples with veins for a while. Vince is going to kill me for that one. Hi, Vince.
I've got a couple of slices for him that was one that I took in my search for type 3s or special type 3s. And each slice has a 75 millimeter long vein, and it's not a vein necessarily with, you know, different regions, but there's kind of multiple veins and little veinlets between them. And I'm hoping that that means that there's more real estate for seeing high pressure pseudomorphs of the more common minerals into their high pressure states.
There's a lot of things like that that haven't actually been completely worked up. There's a lot of research projects for people to work on, including our students. So like I said, I keep a catalog of, okay, I found this in this meteorite and a similar or weirdly different one in this meteorite. And then when students come in, Alex says, what have you got for project? And it's like, well, we could do this. So that's where we're going with this one.
Okay. Very cool. And I love your desk cabinets behind you. I'm scouring eBay trying to find some of those.
They're okay. What you can't see is that there's places where Alex has taped over holes. One set of cabinets came with these cute little holes on the side that let all the air out. And they're all taped up with like duct tape and stuff. So, you know, I would someday love to have somebody actually design the perfect cabinets for desiccant. And then if we ever had any money to do nitrogen feeds through them. So right now we just use lots and lots of desiccant and bake it. We have a little toaster oven that we bake it so that we drive out the moisture and it goes back to the right color and you put it back in the shelf. It's low tech, but it works. So
I'm currently there with my home lab, but I do have a machine for nitrogen, but I haven't bought the bottles and regulators yet, but that's the next step.
we do have a few auto desiccators that, plug in and desiccate without needing to have desiccant put in and baked. And
Yes.
those, we keep the more fragile samples that are likely to be more of a problem with weathering. So doing the best we can on a small budget.
And anyone on the call can please unmute yourself. We'd like to show our thanks and appreciation for Melinda Hutson, doctor, and her time. So crew, have at it.
Thank you so
Thanks
much.
for coming on.
Thank
you very,
you.
very much.
We really,
you,
really
Melinda.
appreciate you.
Hope you can join us
Thank
again
you.
sometime.
I would like to add
Thank you.
one more comment, which is I've seen pictures on Facebook. Some of you have lovely collections, and I hope that you have somebody that you love that will love your collection when you're gone. If you don't, you should consider making arrangements if you want your collection preserved to any of the meteorite labs, us, Arizona, UCLA, New Mexico. The saddest thing that I have done in the last 20 years on a couple of occasions is get called in when somebody has died unexpectedly and their heirs like jumbled all the rocks up and lost all the labels, and we're hoping we could figure it out so they could put them on eBay and sell them.
Ouch.
Oh yes, I have a lovely probable Murchison that comes out of one of those. It was somebody that had bought from ET, and ET knew that the guy really cared about his collection, and the guy died suddenly. His niece and nephew, like I said, jumbled everything. They asked me and Dick to show up. They had some labels. We were able to identify and match up the labels with some of the samples. And there was this, lovely big piece of carbonaceous chondrite that I'm maybe 75% sure is a Murchison,
Wow.
but we couldn't say it. And the guy was going to throw it out, so we took it.
Oh, wow. Good.
Oh my
Good for
God.
you.
So,
Good work.
just be aware, another lab supporter died suddenly. His daughter knew that he wanted to leave his rocks to us, so she gave them to us. None of them had information or labels. Whatever information he had, she didn't know where it came from. We were lucky that he had purchased all of them from Edwin, and Edwin knew what all of them were because there were big hand specimens of like a plain view like this.
Jeez.
Okay.
Uh-huh.
These were really spectacular museum quality samples. And if the provenance had been lost, that would have been terrible. But Edwin
Yes.
knew what each of them were. He had been the one to sell them, and he knew where they came from. And we were lucky that way.
Yeah.
So,
True.
if you've got, I know some of you have really spectacular collections, you value your collections. Make sure your collections are taken care of in case the worst happens. That's all I'm going to say. If you want to leave them to your kids, that's fine. I have no problem with that. If your kids don't care, mine wouldn't. I don't have any to leave them. But, think about what you want to do with them. Dick knew that he was dying, so he spent several months having us come over to his house every other week, and he would pull them out and tell us the stories for each of them. I got notes on, he got them from this person, or he went out and did finding, or this was from this place. And he had a story from a lot of the meteorites. And so we knew not only what the meteorites were, but we had backstories on a lot of them. And he got almost all of them to us before he died. After he died, his daughter gave us a couple of boxes of rocks, most of which were terrestrial that somebody had sent in. And every once in a while there was an NWA. It's like, okay, we'll give this away to somebody as a gift or something, because we don't know what it is. It's probably an NWA, and it was, these were pebble-sized ones that got missed. We have a few that are interesting looking that we kept. We don't know what they are. If we ever wanted to do anything, we'd have to reclassify them as a nova. But, you know, I'm talking out of several hundred meteorites. We're talking about like 6 that
Awesome.
are unknown. So
Right.
that was greatly appreciated. And it was sad because that's when we knew that we were going to lose Dick, because he would never have parted with those meteorites if he thought he had another 10 years. So yeah, but that's just a public service announcement, because I hate to see a beautiful collection get completely destroyed and made useless, because somebody who didn't care wound up in charge of it. I do keep track of when we get a collection from somebody that this group of meteorites is from this particular person.
Right.
We used to hold fundraisers when Dick was alive. None of us have had the energy to do it since he died. We hit COVID, and then it's like, okay, it's still kind of COVID, and yeah, okay. But we had a couple contact us, and they showed up before the fundraiser started, and they had a box, and they had 100 meteorites in it. You know, they ranged from nice slices down to micros, you know, little teeny weeny specks, but it was a nice collection. And basically the guy had been trying to collect one of everything, and it kind of got too expensive. There were too many things, and he did, and he
Sounds like
decided,
me.
and he decided he didn't want to do it anymore, and he donated them to the lab, which was very, very nice. We
Oh,
were
cool.
greatly appreciated. And if you look at our website, somewhere there's like the Hundreds Club, the people who've donated a lot, and he and his wife are there in a picture, and we greatly appreciated it. And we keep track of all of these. If people don't want their rocks traded, cut, done anything, we'll mark it as these are going to just stay like this forever. So we keep track of all of that stuff. That's part of what being a curator is.
I appreciate that public service announcement, and
Yeah.
Topher can attest to this.
I
Actually,
did it 2 weeks
just
ago.
a few weeks ago, he said we're going to have a conversation that might be kind of gloomy to have, but this is something we all have to think about, because, like you said, we don't want them to end up into the wrong hands of family who just they don't get it, they don't get the meteorite, you know, passion. And we also have a lot of conversations about the importance of provenance. How to keep an accurate database, how keep the you know, the COAs and the papers with the meteorite, don't split them up. And so we have a lot of conversations like this. We don't always record them, but it's great to have to hear you say that, and I know that our listeners will appreciate that too. Make them think twice about it.
So yeah, as I said, I'm not a collector, but I am acquisitive for my lab. How's that?
That's fair.
That's fair.
And Melinda, I have a follow-on question to that.
Mhm.
One of the massive challenges is labeling, and I have a number of larger stones that I'm, you know, in the process of classifying. It ranges all the way from, right now mine is based on weight, and I've had the discussion with my son, who's a medical doctor, and you know, he knows and understands. But you know, it hurts me to paint on there and paint a number on it. So some people use stickers, some use photo labs. As a curator, what do you recommend?
As a curator who doesn't want to contaminate my samples, I don't paint on them. We have some that were painted. They have 9-inch numbers and things, but you know, we don't paint on them. Everything that comes in, we enter into a couple of different, we have a combination of a database that we use, you know, spreadsheets and things, but we also have electronic files, and we have old-fashioned lab notebooks that also have copies of things. So we sort of triplicate information, but we try to, you know, you document the weight, you document, or the mass, I should say. You take images, those are all in electronic files. We have servers, so it's not like something that if the computer goes on the fritz, we've lost all the information. So and everything goes in a numbered box. So you notice that there's lots and lots of little white cardboard boxes. So, you know, it's like this split has this number. So we have, you know, a sample that comes in, we cut it. There's a thin section, there's a butt, there's 3 extra pieces from the cut. Each one of those gets a sub number. And, you know, all of that is documented. So we keep track of everything, when it was cut, what it was cut with deionized water, it was cut with oil, it was cut with alcohol, who, you know, who cut it, where did we make the thin sections? So all of that is that's part of the never-ending stream of paperwork that you keep track of. You know, if an earthquake happened and they all fell over, would we find every little piece of everything? I don't know, but we've done, you know, when you've got, you know, 1 to 2 gram pieces and you've got 100 of them, then somebody gave you that as the type specimen. They're in a vial or a box and there's no other way of labeling them. So you do the best you can with documenting what you've got.
Okay, thank you.
I suspect some of my students have already gone and twisted some arms. So again, this varies from student to student. It varies from undergraduate research projects we start with classifications, and a few of them go on to do senior honors theses. And so they will work on something particular for that. And then we have graduate students. Right now we have 4 graduate students. One is working on shergottites, one is working on urolites. Daniel is working on clasts in lunar meteorites, and Vince is working on the shock veins, the silicate
Yes, the
minerals and shock
veins.
veins. You know, 5 years from now, we'll have different students and different projects, and I can't say what we will want or need at that point. I know that Benjamin, who's just started working on urolites, recently classified one. It's been submitted but not yet approved. And he came by and was looking for something else to classify. And I said, I don't have any more unclassified probable urolites. We have a bunch that are already classified, but we don't have any, you know, probable ones that need classification. So he's going to try for what looks like a chondritic shock melt so that he gets another classification under his belt. So right now, if anybody has a probable urolite they want classified, Benjamin would love to do it and add it to his research project. Daniel seems to have, I know nobody wants to cut them. So Daniel is very good at getting a lot of interesting lunar samples. He did go back to somebody and say, pretty please, can we have more of this particular stuff? And the person was very nice about making sure that Daniel got the material. So I think Vince has been wandering around talking about shock veins to people. As I said, there are a number of really nice ones in unclassified stones that Dick left us. So Dick had an eye for shock veins in hand specimens. And so Vince is working on those. George classified a shergotite. I will say that Craig Sleeman recently gifted us a couple of small pieces of an olivine bearing shergotite. I can't remember how you pronounce it. It's a Plateau de something 008. I can never print. I'm not French. I don't do French at all. So, you know, we make do with the samples that we've got. The more samples we've got, the more options we have for our students and for our own research. I will say one of the few Oregon meteorites that we classified, and I should know the names of all the Oregon meteorites in Morrow County. It's called Morrow County because the guy was lost somewhere in Morrow County. He knows he picked it up in the county, but he didn't know exactly where. Alex needed specific shock stages for meteorites for a grant funded project and had picked them out using, the MetBull database. And then when he borrowed them from, I don't know if it was from the museum in New York or the museum in the Smithsonian. He gets from both places sometimes. The sample he was going to use for shock stage S5 wasn't a good shock stage S5. Well, Morrow County was. So we classified that, and that wound up substituting. So it's nice when we can use our own material for a project and not have to borrow sections from someplace else. We're also building up enough of a collection that we have loaned material to other institutions for their research projects. So that's part of what's involved in curation is being able to say, yes, we can loan you material. Yes, we have enough material that you can actually destroy a little bit to do particular types of analysis. And keeping track of all of those. And if they don't come back in 2 years, starting to nag them, saying, can we have our material back now, please? So yeah, what I'm saying is anything you want to give, we will happily take. We will find a use for it at some point because we always do.
Very well put.
Thank you.
Thank you so much again for your time. I'm gonna stop recording now because this is gonna take forever to edit. But
Sorry
you
about
don't
that.
have to go. You don't have to go away.